hurricane forecast, we need to know exactly where the hurricane is at present, how strong it is, which way it's moving. All these have inherent errors in them, but to the extent that we can gauge these in real time, that's, the forecast is likely to be that much better. So to start off, we determine the center location. We look at the past motion, generally over the last 6 to 12 hours, but in some cases when the center is less defined or there's been a reformation of the center, we might look at it for a longer period of time. We determine the intensity, and we do that using satellite classifications if they're over the open ocean, and of course if it's closer to land, we have a variety of other observational platforms. We try as best as we can to develop wind radii for the gale force winds, 50-knot winds, and hurricane force winds. This is difficult at times because we don't always have data at our disposal. And after we do all this, this is sort of like the introductory process, or very preliminary process. We initialize the guidance models, we analyze them, and we QC them, and we begin interrogating the model data to see which ones make sense and which ones do not. And if there is a solution which doesn't seem quite appropriate, then we try to figure out why it is that the model is responding that way. So after we've done this and we feel like we have a good appreciation for the model guidance, we go on and we prepare the forecast track, and we forecast the intensity, the wind radii, and this probably is the most important part. We coordinate the warnings with the various National Weather Service offices, and we also coordinate with federal, state, and local government officials to include FEMA. And we go ahead and we issue the watches and warnings as they warrant. But in so doing, we do coordinate with the WFOs, and they have some say in where the watches and warnings ultimately will be. And then at the very end, of course, we prepare and then issue the forecast. It's a very stressful process, I've come to find out. And I'm not exactly used to it since this is still my first year, but for the veteran hurricane forecasters, the senior forecasters, I mean, they've done this for 10 or 20 years, they make it look easy. But for me, this is one of my first years doing this, so I still need a little more practice. This is what the forecast cycle looks like. The forecast cycle begins at the synoptic time, so 0, 6, 12, or 18 Zulu. And within about 45 minutes, this is when we receive the satellite classifications from SAB, which is located up in Camp Springs at NCEP, and from TAFB. And shortly thereafter, we're able to take this information along with our own estimate of where the center is, and we initialize the guidance models. And this all occurs within the first hour. And to be sure, we're not sitting around idle. We're sitting around and we're looking at the model. We're looking at the model data. We're interpreting it. We're seeing the solutions make sense. And once we receive the new model guidance, we can compare it to the old guidance and begin to prepare the forecast, the track, the intensity, the wind radii. So within 2 hours after synoptic time, this is when the coordination with the Weather Service offices begins, and with the Department of Defense on the Hurricane Hotline. This is when the limelight is really on the hurricane specialist, because where I feel that we're earning our money, because before this time we've decided where the watches and warnings have to be, what the forecast track is, but this is where it's communicated to others, and so that they can be included in on the decision-making process. So within 3 hours, we're looking at the advisory deadline, and everything must be out. That includes the writing the discussion, and that usually takes place in this last hour, even though we may try to start it even before the coordination time. And even after that's done, you notice that we have a little bit of downtime here between, say, 3 and 6 hours. We do have some other conference calls with FEMA, and on some occasions with other government officials, but this is a time for us to do other things in the office. We conduct interviews with the news media, we look at scheduling issues, we determine where the reconnaissance planes have to go, and so this is, there is a little bit of downtime there, but not very much before the next advisory cycle starts. And so most of you are familiar with this. I imagine that we issue advisories at 5, 11, 5, and 11, and you might wonder why we do that, and that's because the advisory process in general takes about 3 hours, and that's how long it takes to compose the entire forecast package, and so that's about 3 hours after all the synoptic time. So that's why we've settled on those times, and this was a process this process has been around for quite some time, and we've actually reduced it by an hour since the 1980s. We issue a forecast out to 5 days. This is something which is fairly new, beginning in the year 2003, only after we tested it in-house for a number of years. And there is a move now within the Hurricane Center, and actually within NCEP, to extend these forecasts out to 7 days. And we just finished developing our 5-year strategic plan. And as part of that, we've decided that we are going to begin testing whether we can forecast out to 7 days, both intensity and track. And I believe next year is the first year that we're doing that in-house. And if after a number of years, if we feel that there is skill there, then we will begin to make these public. With regard to the wind radii forecast, those go out to 72 hours, and the evidence that we have so far indicates that we're not able to extend those wind radii, and they may not even be skillful even out beyond 48 hours. So because of that, I think that we'll see these stay where they are, and we'll try to improve what we have been doing. Of course, included in this are the watches and warnings, and there's coordination with SPC for the tornado threat, HPC for the rainfall threat, and then OPC for the marine interests. And there's also some inclusion of a storm surge statement as the center approaches the coast. So to begin the forecast process, these are the various types of data which we're accustomed to using. Data from both the polar orbiting and geostationary satellites, reconnaissance aircraft when a storm is near land, radar also when a storm is within about 250 miles of the coast, and other land stations. Ships and buoys, but these can be sparse at times, and we certainly don't rely on them. And then dropsondes both within the hurricane and outside the hurricane. We have a program called that deals with targeted observations. So as a hurricane nears the U.S. coastline, we take the NOAA G4 aircraft, and it flies around the storm's periphery. And the dropsondes, which descend within the periphery of the storm, they are able to deliver vital data which are assimilated within the numerical model guidance, and has over time it resulted in improvements in the forecast track on the order of maybe 10 or 20%. So this is just summing up the same thing that I had before, sort of like another slide, the satellite imagery, microwave data, scatterometer data, reconnaissance, dropsondes, SFMR, and radar data. And last but not least, surface observations. But many of those, we often don't get those in real time, and if they do, if we do get them, they're rarely in the area of maximum winds. So in order to forecast, the intensity, we start off with this definition. This is what we use. The maximum sustained surface wind is defined as the strongest wind speed at a height of about 10 meters, and this gives you an idea of what that looks like with regard to the typical ASOS station. And this is associated with the circulation at any point in time. What's key here is that it cannot be part of a transient feature, sort of, for example, like a mesocyclone circulating around the storm circulation. This, of course, the intensity is estimated almost always, and is rarely measured directly. This is very key. We rarely get measurements of the absolute intensity. And as a starting point, we often use the central pressure. We can use a pressure-wind relationship, which correlates pressure with wind speed, but that can often be in error by maybe 1 or 2 Saffir-Simpson hurricane categories.